In this video, we're going to look at a couple integrals that involve e to the x and natural log of x. But to lead into that, we're going to do a couple of other integrals here. And in particular, part C here is going to lead into the natural log integral. So how would we do the integral of x to the 6th dx? Well, notice it's just x to the 7th over 7 plus c. So that's the power rule for integrals that we're doing there, right? Remember, we raise this power up by 1 to get x to the 7th and divide by that number. And what it means to say that the integral of this is that the derivative of this is this. Okay, now how would we do the integral of 1 over x cubed? Well, we rewrite this as x to the negative 3. And the integral of x to the negative 3 is going to be x to the negative 2 over negative 2 plus c. Okay, now we could simplify that, but let's not do that. In fact, the whole point of doing this is because I want to ask about part C here. What is the integral of 1 over x? Now, notice we could write 1 over x as x to the negative 1 power. But what if we tried to use the power rule here? What would the power rule say? Well, wouldn't it say x to the 0 over 0 plus c? Well, that doesn't make sense. You can't divide by 0. So this is not correct. In fact, if we look at the power rule for integrals, it says that the way to take the integral of x to the n is x to the n plus 1 over n plus 1 plus c. It says it works for every n except n equals negative 1, and that's exactly the case that we were in. So the question is, how do you do the integral of x to the negative 1 power then? Well, remember, we have 1 over x here. We're trying to come up with a function where the derivative is 1 over x. Well, we know a function where the derivative is 1 over x. Isn't it natural log of x plus c? Okay, isn't the derivative of natural log of x 1 over x? Now, for technical reasons, we're actually going to do natural log of the absolute value of x. I'll explain why we do that in just a minute. But the integral of 1 over x is actually natural log of x, or natural log of the absolute value of x. And that's the one case that we're missing in the power rule. The power rule tells you how to do the integral of x to the n for every power of n except n equals negative 1, right? So how do we do the integral of x to the negative 1? Well, x to the negative 1 is just 1 over x, and the integral is this. Now let's recall these two derivative formulas. The fact that the derivative of e to the x is e to the x means that the integral of e to the x, or the antiderivative of e to the x, is going to be e to the x. So this derivative formula gives us this integral formula. Integral of e to the x is e to the x plus c. And same thing here. The fact that the derivative of natural log of x is 1 over x means that the integral of 1 over x is going to be natural log of x plus c. And again, for technical reasons, which I'll mention in just a second, we're going to use natural log of the absolute value of x. So let's do a couple examples. How could we evaluate the integral? Well, we have the integral of 5e to the x. We know how to do the integral of e to the x. It's just e to the x. Well, what about 5e to the x? Well, remember, the integral of a constant times a function is just going to be the constant times the integral of the function. So the answer is just going to be 5e to the x. In fact, you could bring this 5 out in front of this integral if we wanted to, and rewrite this as 5e to the x plus c. Okay, and remember, we don't need to put the e to the x plus c in parentheses because we're just tacking on the plus c on the end here. So the integral of 5e to the x is actually just 5e to the x. Integral of 13e to the x is just going to be 13e to the x, and of course the plus c. Now what about the integral of 7 over x? Well, 7 over x is just 7 times 1 over x, so we could take the 7 out front, and we end up getting that this is 7 times natural log of the absolute value of x plus c. Okay, and that's our answer. So the integral of 7 over x is just going to be 7 times natural log of the absolute value of x. Or for another number, integral of 13 over x is going to be 13 times the natural log of the absolute value of x plus c. Let's do one more. Now, I have a question here. Can we take this 8 and bring it out front? And what about this 12 and the 2? Can we bring those out front? Actually, no, we can't. Why can't we take this 8 out front? Well, if this whole rest of this thing inside here were in parentheses and it was 8 times this entire thing, then the 8 could come out front. But as it is right now, the 8 cannot come out front. And same thing with the 12. We can't take the 12 out front right now, or the 2. Now, what you could do is break this apart into 3 different integrals. I don't recommend doing this, but what you could do is write this as the integral of 8x to the 4th dx plus the integral of 12 e to the x dx minus the integral of 2 over x dx. And then you could take this 8 out front, you could take this 12 out front, and you could take this 2 out front. And then work out all these integrals. Make sure to only put one c on the end, not 3 c's. So you could break it apart into 3 different integrals like this. But actually, I don't think we need to do this. I think we can kind of do each of these in our head. In fact, what's the integral of 8x to the fourth? Well, isn't it 8x to the fifth over 5? What's the integral of 12 e to the x? Isn't it just 12 e to the x? And then minus what's the integral of 2 over x? Is going to be 2 times natural log of the absolute value of x. And we'll put our plus c on the end. Now, last of all, why do we have the integral of 1 over x dx being natural log of the absolute value of x? Why do we have the absolute value instead of just x? Because this formula just kind of makes it look like, well, the integral of 1 over x should just be natural log of x. Well, the reason is because this formula only works if x is greater than 0. The derivative natural log of x is 1 over x if x is greater than 0, because you can't even take natural log of a negative number. It turns out, though, that the derivative natural log of the absolute value of x is also 1 over x, and that works for all x other than x equals 0. So why is this the case? Well, graphically, what's going on here? Well, we have the function natural log of x here in blue, and it turns out that the derivative of natural log of x is 1 over x, this function in red. So what that means, if you take any point on the graph here and you look at the slope of the tangent line here on the blue function, that'll be how high the red function is. So for example, if we're at 5 here, and we look at the graph of natural log of x, and we ask, what's the slope of the tangent line? The slope of the tangent line is 0.2 or 1/5. Well, that's also the height of this point, right? The point on 1 over x there at x equals 5 would be 1/5 or 0.2. So whatever the slope is there, that's how high the point is. And that works for any point on the graph. So it turns out that the derivative of the blue function is the red function. But notice, though, that the red function actually exists over here, whereas the blue function doesn't. Notice if we zoom out a little bit, the blue function, natural log, only is defined over here where x is greater than 0. Well, is there another blue function over here that if we took the derivative of that, we would get this? And it turns out there is. And that function is this. Now, what is this function? Well, this entire function here is natural log of the absolute value of x. And notice it's defined even for negative numbers. You can plug in a negative value for x. And this is what the graph of natural log of the absolute value of x is. And it turns out that the derivative of this is 1 over x. So natural log of x only has this one piece of the blue function. Natural log of the absolute value of x includes both pieces. And it's actually the derivative of this blue function that gives us both pieces of the 1 over x function, right? So remember, this red function here, both sides, is 1 over x. So we have this formula here, and this formula tells us that the integral of 1 over x is natural log of the absolute value of x. That's the more general formula. That works even if x is a negative number. Whereas this one up here only works if x is greater than 0. So that's why we say the integral of 1 over x dx is natural log of the absolute value of x plus c.